Hi, everyone. My name is George Chapman from Energy Solutions, and I am thrilled to welcome you to our session on gas heat pump water heaters. So we've got a great session for you today. Um, we've got some tremendous speakers, and I am really looking forward to this one. It's been a topic that I was first introduced at the Hot Water Forum, my first one 8, 9, 10 years ago. And there's been tremendous growth for the product category, and we've got a lot of great information to kind of update everybody. So I'm thrilled to be part of it today. So first and foremost, I want to thank all of our sponsors and ACEEE Ally members for their support of the Hot Water Forum. As a member of the steering committee, incredibly grateful for everybody who helps make this one happen. So thank you for all of those folks. Now you'll see the chat box on the right-hand side. You can ask questions in there. Please try to refrain from like a lot of other comments, because we want to be able to monitor those questions in the chat box, either so that the speakers can address them directly, or so that we can bring them to the Zoom room afterwards and have a conversation on them. So if we kind of keep that a little bit leaner, it allows us to pull out all of those comments and questions so that we make sure that the speakers are able to speak to them. All right, so on the left-hand side of your app, you've got places where you can network, you can engage program participants, visit sponsor pages. You can win free registration to the 2023 in-person Hot Water Forum in Mission Hills, California. Resources section will have a list of attendees for downloading and help us plan for future Hot Water Forums by completing the conference evaluation. It is really helpful, and if you do so with a testimonial, you can get $25 off next year's conference, which I'm sure you'll be using. Finally, presentations will be available for on-demand viewing for registered attendees for the Socio platform within a couple of days. They'll remain available for viewing until May. The slides themselves can be found in the program participants section. All right. So first up, we have Mila Barber and James Allen from Fortis, BC. They'll be talking from pilot to program for advancing GHP technologies. And I will let them take it away. But I've known Mila for many years and know the project that Fortis has been working on, and I'm excited to hear what's next. So here they are.
All right. Thanks, everyone. And thanks, George. It's nice to see a friendly face. My name is Mila Barber. I'm a program manager for heat pump technologies on Fortis BC's conservation and energy management team. And I'm really happy to be joined by my colleague, James Allen, who's a manager for our conservation and energy management team. As today, we're going to take you on a journey. From pilot to program, so to speak. We're going to talk about how we identified an opportunity and built a business case to support gas heat pump technologies, specifically today, commercial gas absorption heat pumps. We're going to share some lessons learned from our pilots at a nice high level, because really, we have to prime the market to validate our assumptions before we back a technology and understand how it's really going to work for our customers. And then lastly, I'm really excited because James is going to talk about how we're going to be launching a new prescriptive rebate offer and kind of what our marketing and communication strategy is going to be in introducing a very new technology to our marketplace. But before we begin, I want to tell folks all about Fortis BC. We're a combined natural gas and electric utility servicing 1.1 million natural gas customers and approximately 350,000 electric customers. And so we're in beautiful British Columbia, Canada. We have a lot of innovative rebate and sustainable programs. We're really ramping up our RNG, and we have a big 30 by 30 commitment, which aims to reduce our customers' emissions by 30% by the year 2030. And one way we're doing that out of many is focusing on energy efficiency. And today we're going to be talking about gas heat pumps as a really viable solution and to get our customers to that next tier of energy savings. So why should you care? Why do folks on the line here, why are you attending to learn about gas heat pumps? Well, like I said, there's a huge swing in efficiencies compared to conventional gas equipment when you're looking at gas heat pumps with the COPs upwards to 1.3 to 1.6. Another reason you should care is this technology category can help support gas utility greenhouse gas emission reductions. We know that they can operate off renewable gases as well, such as RNG and hydrogen, giving us that opportunity to get to net zero emissions. As well, these technologies support seamless integration into existing systems. So it's very retrofit friendly. And we see this as a great opportunity to reduce emissions in existing buildings. And so we're really excited to be here to talk about one of the first market-wide rebate programs to support commercial gas absorption heat pumps. You're going to find out it's prescriptive. There's going to be lots of support and education available because we really understand that it takes a village and it takes hand-holding when you're introducing a new technology to the market. And then why do we care so much about gas heat pumps? Obviously, we want to provide safe, reliable, and affordable energy to our customers. And we want to make sure that there's energy savings and they can achieve their climate action targets. But we're really, responding to our provincial and federal climate mandates that are coming. We were marching towards the Pan-Canadian Framework, which stated that all space and water heating efficiencies had to be above 100% for both residential and commercial sectors. But most recently, our province, through Clean BC, announced that 100% efficiency threshold must be achieved by 2030 or earlier. So really, when you're looking at our conventional equipment, it won't get to that next tier, but with heat pump technology, we're able to incorporate additional energy from the outside ambient air. So you're getting far greater output than input of energy required to get those efficiencies greater than 100%.
Hey, Mila, just real quickly, I think you're presenting just the other PowerPoint screen, so I don't think folks are seeing the slides progress.
Oh, is it not progressing?
I think you have it on your other screen. So if you just share the other screen, I think you'll be good to go.
Okay, let's see. Stop sharing. Let's try this again. Window. Can you see this okay?
You just go full screen.
Are the slides changing?
They are, but they're just not full screen. But
okay, I think we'll have to make do. I'm not too sure why it won't. Can you see the commercial gap pilot journey?
No.
Now can you?
Yes.
Okay, we're going to go in this mode for now. Thank you for the heads up on that because I can't see anybody else. So I'm going to take you guys on a journey through our pilots that we've implemented since 2019 to 2022. We originally thought, we're going to start with domestic hot water, and that's why we're here at the Hot Water Forum. But then we, wanted to learn more about how this system works, how we can optimize it and get the most cost-effective solution for our customers. So we are going to talk about our experience, changing out the existing system to tankless, modulating, condensing equipment, our experience tying into multiple end uses for space heating and ventilation, really to support our program objectives with learning how we can make a cost-effective rebate offer. So our first pilot journey started back in 2019, where we installed 14 Rover Gap A units across 7 multifamily sites to supply heating for domestic hot water. It was a really, really promising trial. We realized energy savings of up to 21% and noticed that the gap efficiencies were well above 100%. However, there were some learnings. We were noticing that the overall system efficiency was dipping below 100%, and we wanted to understand why. we realized that some of these systems are actually oversized, and domestic hot water load profiles are very vastly different across, different archetypes, and right sizing is very critical for this technology, because the harder it works, the greater the savings will be. So we did some testing, turning one unit off and had just one unit running, and we saw actually greater energy savings. And then we realized that the existing boiler was short cycling. So more sophisticated controls were important to help have this system talk more efficiently to one another, which led us to an additional trial where we wanted to take out those big mid-efficient boilers, and we want to install tankless units. These are Norwitz units that can modulate and have better flow sequencing control with the Rober units. And by doing this one thing, we saw a 14% swing in energy savings from our previous evaluation. So we went from 21% to 35.2% energy savings. Throughout this experience too, we realized that a delta T of 6 degrees must be maintained in order to have that system efficiency be well above 100%. And then we also noted that preferred retrofit would include a sequence controller. So flow sequencing is super important, again, to have these units talk properly with the Rober system and to really drive greater savings. Next, we wanted to understand how this could tie into a space heating scenario. So domestic hot water is quite intermittent in nature. And like I said, it can change dramatically depending on the archetype. And we know space heating load is much more of a consistent demand here in British Columbia. And so we took one of the 2 GAP units that was a participant already enrolled in the program, and we tied that as a tandem system into the space heating boiler. And what we found is it increased the system's COP. We saw that there was greater potential for savings. So using these Rober units to tie into multiple end uses drives greater savings for our customers. We understood that the preferred retrofit would be a condensing boiler with sequencing control. So it was a cast iron boiler that we were dealing with. And so there was definitely limitations, and we didn't want to have that try to condense. So definitely some more opportunities to further drive savings. But we're also looking at right sizing. It's super critical when you're doing these kind of, it's not really a hybrid system, we're calling it a tandem system, because if you size it too small, it'll never operate. But if you can get that cost-effective play, then you can really drive energy savings with these Rober units. Lastly, on the theme of tying into end uses, we're looking at ventilation. So you might ask why? Well, makeup air units or air handling units are typically on the roof next to the domestic hot water equipment. So there is this opportunity to further increase the system COP. We also think that this opportunity could help increase the delta T and the GAP efficiency. We think there'll be minimal reduction in performance in cold climate, and that this GAP unit supporting would even be more efficient than a condensing makeup air unit. And then lastly, it could have a nice opportunity for customers to not have to deal with condensate issues that are found with condensing makeup air units. So we're putting this theory to the test. We've installed a coil, as you can see here on the drawings, and we're going to be monitoring this. It was installed a couple of weeks ago, so we're going to have interim results in the summer and really finish our evaluation results for next January. But really, the whole point of this is to say, how can we make this more cost effective? How can we drive further savings? And I think ventilation is going to be one great option. So in summary, when we look at all of our field evaluations, we obtained great customer acceptance from the technology, from not only the building owners, who noticed zero interruption with their space heating or domestic hot water services, but from contractors. There is mitigating fears or uncertainty around ammonia. mitigating any uncertainty around installing this equipment. Really, they said that it was no different than installing a condensing boiler, which was fabulous to hear. But they said that they would recommend this technology, and that is super important when you're getting feedback, because if you're going to think about how this rebate program is going to go to market and how people are going to react. So this field trial showed promising customer acceptance. But a key learning was the ability to further drive efficiencies by tying into multiple end uses. Like I said, the harder the system performs, the greater the energy savings will be. Another key learning is proper flow sequencing controls and system right-sizing strategies are really important to maintaining that delta T in system performance. So if you want to be well over 100% system efficiencies, those are two aspects you really need to incorporate. And then again, when we do this, we do these pilot programs, we identify ways to improve cost effectiveness. And then that could be as simple as avoiding craning fees from going on the roof to finding maybe ground floor installations, or looking at companion components and packaging boilers or skidded components to really help drive down costs. So I really urge folks to continue to conduct field pilots in their service territories to help prime the market and to really understand how they can make it cost effective. All right. Well, I'm now going to pass it off to James, who's going to talk about program design and market engagement strategy.
Thank you, Mila. Very well done. So it isn't very often that the program team, we manage a whole bunch of electric and natural gas energy efficiency programs throughout British Columbia, really comes across a technology that is, frankly, that impactful as gas heat pumps were, as compared to, say, some of the existing boiler and hot water systems that we have out there. And that's the fine work that our innovative technology folks do. And once they have all those learnings, it really, well, that's fantastic. We have this great new technology. What the heck do we do with it? How do we actually get this technology to be in the grubby little hands of our customers and make sure that they're happy about the whole process? So, for the folks of you that are in program design, this might be a very interesting section. For the folks of you that are more on the customer and maybe on the trade side, maybe not as interesting, but hopefully this sort of pulls the veil back of how utility programs take a look at when these emerging innovative technologies, and particularly this gas heat pump technology, comes. Because I'm going to tell you about a little dirty secret of the utility world. And it's the same as engineers. If you look at any program manager, or if you take a look at any engineer, take a look at their keyboard and see which of those letters are sort of rubbed out the most. And it's usually that C and the V. What we like to do is we like to find a program that someone else has implemented, and learn about the best practices, where some of the drawbacks of their program, take it to our jurisdiction, maybe do a little tweaks here and there, and we roll it out. Simple as that. Now, for this one, we aren't as lucky. To the best of our knowledge, no one else has put out call it a market advance gas heat pump program. So we're sort of first out of the gate, and we're having to learn these lessons ourselves. So what do we have? We have this excellent technology that really is an incremental, or I'd say more even a revolutionary step with respect to efficiency for a natural gas appliance. We're lucky that it is commercially available, and even for our fine folks up in the tundra, yes, we can get this. It is 20 to 30% more efficient, and specifically for us up north, it's not as outdoor temperature sensitive as electric heat pumps. So where electric heat pumps can't work in any application, this one has a little bit better opportunity. However, this technology, as great as it is, does have some drawback. Firstly, no one really knows about it, right? Maybe the fine folks on this call it a very technical subset of the population, might have some more awareness, but for the folks that we work with, not so much. There's also very few folks that are providing this technology out in market. So there's the scaling activity that needs to be done in order to get this out there. And certainly we're in a situation in BC because of all the information that Mila suggested. We have some very aggressive policy direction towards greenhouse gas reduction, where we're competing with other electrification options out there. And it isn't necessarily just a one-to-one retrofit. You can't just yank out your existing condensing boilers, condensing commercial hot water systems and just pop in a heat pump in many applications to get it running really well. There is some backup and additional controls that is necessary to really get those savings. So if I get you just to advance there, Mila. So what we did is, now that we have all this data, great data from our innovative technology groups, we went out to market and say, hey, who knows about this? Tell me what you know about this technology. And we got a third-party implementer, probably one that many of you utilities work with, to try to find out that answer. And unsurprisingly, our hypothesis was proven, and very, very few folks knew about our program other than the folks that participated in our pilot, who had excellent awareness because of all the work that our innovative technologies team did. So that means we have low awareness with trade allies, with energy consultants, with distributors, with customers, with energy specialists. It gets a little dire, right, if you start taking a look at it. So we are really at that stage that if we are comparing ourselves to, say, the tech industry, we're at an app that has no demand, but has really big promise. And we have to start to think about program design in that way. So if I get Mila to advance again. So we created a bit of a pathway of how we are going to bring this product out to market. I would say we're very close to having um, many of our, our questions answered about the actual performance of the technology. So now what we really have to do is start seeding that market with products, learn about not just the technical aspects, but the market journey aspects that our customers, trade allies, engineers, and consultants work with. So the first phase that we're doing with this technology is, call it maybe an expanded pilot. And the pilot's less on technology, but we're looking to install about a dozen, perhaps even as high as 20 systems in our service territory with very high incentives attached to it to try to get folks to try this technology and see how it performs and get some market feedback, some case studies that we can use to more broadly educate the market. The second phase of this, and we're actually quite close on this one, is an actual prescriptive program and launch that out there so folks can get those incentives right away. We're also looking to do a point of sale for certain vendors. And then lastly, and this is really the big one, is we are doing a very detailed trade ally network offer and outreach that involves webinars, direct outreach, creating our own training center at FortisBC for people to put their hands on this technology and really understand how it works out. And that is what our goal is really to transform the entire market to have zero awareness to at least know of gas heat pumps, and primarily, or ideally even, try installing at least one. So if I get you to advance again, Mila. So in terms of creating a program, how do we sort of deal with these challenges and solutions? So one, we talked about low awareness. So yes, as I mentioned before, we're going to have this very advanced trade ally consultant engagement that has a third party implementing it on our behalf to make sure that it's constantly resourced out there. Our challenge with supply chain, what we're looking to do is we are actively recruiting point of sale partners, and with the work that Mila's group has done with manufacturers, bring those, sort of do a bit of speed dating to connect the distributors with the manufacturers and market and make sure that they can stock and provide gas heat pumps today in our market. With respect to electrification, certainly customer choice, electrification is always a great option out there, but gas still has a very relevant role to play. Our role is to develop quite a bit of case studies. So we hope that our utility will be one of the first folks to market to have a lot of those ready that perhaps other utilities can copy later on down the line. The challenge with having conventional backup, what we're going to do is, a part of our incentive structure, really have a support for right sizing the system out there so that it's not just an incentive for just doing the gas heat pump unit itself, but also some additional support for making the system work properly. And then, because there is a higher cost than traditional technologies, and maybe higher costs than some electric heat pump technologies, and uncertainty with respect to savings, what we're looking to do is, unlike a lot of times when we bring new technologies to market, we put in our custom program, right? Because we can study each one. But what we're doing is we're looking to actually roll this out as a prescriptive incentive instead of a custom one, so folks have certainty of what their incentive is going to be. If I could advance one more, please. So in terms of our incentive structure, the way it works out is we have a incentive just for to do the energy study and then another incentive for the actual unit itself. But what's sort of unique about our incentive structure is that we then have the system bonus, whereby the more that they integrate end uses, the more incentive that they get from FortisBC. If I could get you to advance one more slide there, Mila. And again, I think I did describe in some detail in terms of market development, but we are going to be putting on webinars and in-person training beginning this year. We have signed the contract associated with that. We're going to be working with various folks like GTC to develop best practice manuals, and then also starting to work on having a well-communicated, well-developed gas heat pump manufacturer, distributor, and contractor network in British Columbia. And as I mentioned before, we're going to convert 2 of our buildings, ideally, to actually be training centers in British Columbia to demonstrate this technology with all the measurement and verification bells and whistles, and hope to invite consultants and trade allies out to our own facility. And lastly, we're looking at contractor spiffs and other tools like calculators out there, and I think we'll probably be first to market with a lot of that stuff. So next slide. So that's really what we're planning to with respect to our program, and really the call to action for you fine folks out there is if you are a manufacturer of gas heat pumps or any technology that saves energy, we definitely want to hear from you. We do have a robust program that Mila manages to do pilots, and so the call to action is please visit that page, please contact us. We'd love to hear from you. And I would say that is it. Thank you.
Perfect. Thanks, everyone.
Hello, if my audio is working, hopefully everyone can hear me. If not, someone let me know. Been a few technical issues here on our side. All right, great. Sounds like you can hear me. My name is, I'm not sure if the introduction came through. My name is Ryan Kerr, Senior Manager, Emerging Technologies here at GTI. I'm going to try to get through this quickly, but talk a little bit about gas heat pumps as well, residential in particular, and combi space and water heating specifically. So just spend a moment talking about GTI and our decarbonization strategy. Gas heat pumps, although I think Fortis did a great job of introducing that as a general topic. Residential combi field experience, some lab evaluations that we have done and are forthcoming, which is exciting and will prepare us well for next winter heating season. And then some of the good work outside of what Fortis is doing in the program development and deployment space. So as it relates to decarbonizing buildings, we see really 2 primary pathways, a fuel-fired pathway and electric pathway. GTI is doing a lot of research and development in both of these areas. Today we'll cover the fuel-fired pathway, which focuses on colder climates, existing buildings, and leveraging the direct use of natural gas as it is currently delivered to buildings. The vast majority in the areas that we're talking about, but certainly more than half of homes with domestic hot water and space heat delivered through gas. Excuse me. So there's really kind of 2 approaches to this, and together we can do more, leveraging both of them. So energy efficiency, which will be the focus today, but also adding decarbonized fuels. So hydrogen or renewable natural gas, are a way to decarbonize the molecules that are coming to your house. So supplementing natural gas. There's a tremendous amount of activity in hydrogen in particular, and we're starting to deploy that in earnest in gas systems across North America. So if you see here, That's a picture of some testing that we've been doing here at GTI. That's 40%, or rather 30% hydrogen, 70% methane or natural gas. So we've been doing a lot of blending testing. But this is a simple diagram to show that we can reduce emissions by roughly 50% through renewable natural gas and hydrogen. We can reduce emissions by roughly 60% through advanced technologies like gas heat pumps. But if we put them together, we can get to significant savings, like 80% greenhouse gas emission reductions. So gas heat pumps, why do we care? Really, it's about best-in-class operating efficiency. In space heating and water heating in particular, we're getting upwards of 97, 98% efficiency. We can't crack 100 without a heat pump technology. It's really that simple. This diagram shows you for residential water heat that even above best-in-class tankless, you get a significant bump in efficiency with a gas heat pump water heater, and with theoretically lower installed costs. But this is really true across the board for space and water heat in buildings. They also commonly use natural refrigerants, which are all of the technologies that we're talking about today use natural refrigerants, ammonia in particular, which is important as it relates to the greenhouse gas picture for operations and commissioning and decommissioning. So I won't spend too much time on this, but there are different types of gas heat pump technologies: vapor compression, which are typically for larger systems, commercial HVAC, can do cooling and heating; absorption, which we'll be focusing on today; and then thermal compression and acoustic. So one size does not fits all. Some of these are better at some things, some are better at others. Absorption is particularly good at scaling down, so we can scale it down for residential water heat or space heat. The OEMs or manufacturers, technology developers that are bolded to the right are systems for which we are testing or we will be testing shortly in our laboratories. So just a quick recap of what we've done. Water heating we've been working on for more than 10 years and have recently deployed systems in California, worked with a number of OEMs and demonstrated over 120% efficiency. For space heat and combis, this has been a particular focus, certainly for cold climate residential buildings. Space heating is really the most significant load. And so reducing energy and emissions there is of critical importance. So we'll spend the balance of the presentation really talking about efforts there. We also have a large collaborative of utilities working with Renai to deploy for a large-scale pilot of residential gas heat pump technologies that is currently ongoing. You heard about commercial hot water from Fortis BC. So that's a commercially available technology, and then also the commercial VRF systems. I'll talk a little bit about the availability of equipment and commercialization timeline towards the end. So combi system is fairly straightforward. You have an outdoor unit, the gas heat pump, that serves both your domestic hot water and space heating loads. There's an exchange coil and a hot water tank like you'd have for a solar thermal system. And then you replace your furnace with a hydronic air handler with a coil where you, instead of refrigerant, you're using water or glycol water mix in colder climates where you can have freezing. And you can see here the connection to the hydronic air handler in one of the demonstration sites. So we worked with SMTI to deploy 7 of these systems in a hydronic combi approach, demonstrating 140 AFUE. And a few things I'll highlight here. One was that we noticed that there's a fair amount of sort of on-site engineering that's required, or certainly connections. You can see what we call the control board mounted on the wall in the picture on the left. Halfway through the project, we started making those off-site to make the connections more straightforward. You also see this with electric air-to-water systems. And SMTI has taken that a step further and started to integrate some of those controls into their air handler, which is a positive development. And then on the right, you can see the hot water tank. The other thing I'll highlight is the controls are really of critical importance, especially as you're moving from technology development to product development. We've really demonstrated the technology works. Now it's about how do we package it, how do we control it, and so there's been a lot of lessons learned associated with how do we control it, how do we optimize efficiency, reducing cycling, and most efficiently delivering both space and water heat. So we tested the system in the lab, validating the AFUE, and starting to develop performance curves that then we can use in models to look at what energy savings and performance looks like across a number of different buildings. We'll be testing the new Anisi system that SMTI deployed at the AHR show. You can see a picture of their booth there. So we'll be evaluating the thermostat and domestic hot water controls, as well as looking at part load performance and developing curves again to be able to evaluate these for further deployment, in particular in expectation of the winter heating season for 2022-23. Similarly, we're also looking at 3 other systems that are being brought to market in this same space, in this residential space heat, water heat. So the first one is this Homey Vicot system. Homey is a Canadian distributor that's bringing this to market. Vicot's a Chinese company. They have a commercially available gas heat pump in China, and they're bringing that to the United States. We've tested their larger system for commercial applications. We have the smaller residential scale unit coming. You can see that picture on the bottom right-hand corner. Operates similarly. It's an absorption system like the SMTI or an EC. Then Thermolift, that's a picture from FortisBC actually. They've got some of these deployed. Recently, Enbridge commissioned one of these up in Ontario. So that's very encouraging. We'll have one of these in our labs any day. So this is a thermal compression technology that offers really high efficiencies and can do cooling. So that's an exciting development. Then finally, the Robur K18. So you heard about Robur in commercial water heating. This is a residential scale unit that's been available in Europe, and we're going to be testing that here in North America and working to North Americanize it, from an electric perspective and also an application perspective. So moving away from sort of hydronic distributed heat to a forced air application, which is the majority of North American applications. So I think the takeaway here is there's been a lot of product development going on. We've refined the system, reduced cost, increased reliability, and now there are a number of systems that are coming to market in the next year or two. I think the fact that we have 4 front runners for residential combi is very encouraging. And the expectation is that they will be coming onto the market in the next 12 to 18 months. And our lab testing will reveal a lot of good information about their readiness, their controls, their efficiency, and will also help us prepare for making decisions about future deployments. I'll try to race through these. So the takeaway here, I think, is CEE, with a number of partners, has developed this advanced tier that really creates room for gas heat pumps and energy efficiency programs. This is an important development and something that others are working on, but basically trying to do the spade work now to be ready with program offerings when these systems hit the market. In that area, the North American Gas Heat Pump Collaborative is doing a lot of important spade work as it relates to readying the market, creating programs. You can see all the things that they're working on here, and they represent a pretty good portion of residential customers across North America. And kind of bringing it all together, the work that we're doing in the laboratory will help us make decisions about what systems we'd like to deploy as part of this demo in particular, combining our laboratory results with modeling to extrapolate to Washington Gas territory, in this case in Maryland, and then validating performance in the field from what we saw in the lab and working towards a new measure in the North Atlantic TRM and gas heat pump offerings in Maryland and hopefully throughout North America. So I'm going to leave it there and pass it on to our last presenter. Thank you very much.
Great, thanks so much, Ryan. Really appreciate that presentation. Incredible how much you're able to fit in that amount of time. You guys are definitely keeping busy. So in order to keep us on track a little bit, I just wanted to transition briefly to Magnus Ekblad from HeatAmp, who will give a presentation regarding moving towards a cost-effective residential retrofit gas heat pump water heater. So Magnus, you are up.
Thank you very much, George. So I hope you can all see my screen here. There's been some technical hardships here, but so my name is Magnus. I'm the CEO of HeatAmp, and I will finish off this gas heat pump session by talking about HeatAmp, who we are, our mission, and what we learned through the years, because we've been working with heat pumps and these kind of technologies for quite a long time. And with our mission, what do we see that we have that makes a difference? How are we going to succeed when it comes to competitive advantages, but also how are we going to commercialize this technology? Because I think that is what it's all about. We need gas heat pumps on the market. We need them commercialized, and it's a challenge, but I think we are really on the way in. And there's several interesting technologies on the way. So our mission, so we are solely focusing on residential. We are focusing on drop-in replacement for water heaters, conventional water heaters. So we really try to have this focus, and we see that we have this mission. So in summary, we've been working with this technology for quite a long time, more than 7 years. So we have a lot of experience from the field, both from heating and cooling, but also the absorption technologies. We have our focus on residential drop-in replacement, and we are working a lot with robustness and cost effectiveness, because we see to be able to bring something to the residential market, we need to demonstrate both robustness and cost effectiveness, because otherwise we will not be able to launch something on the broad spectrum. Then of course compactness, scalability, and future proofing is also very important aspects of being able to bring a technology like this to the market. We have been working with the US and North America for quite a long time. We are collaborating with several OEMs, North American OEMs, and we also are working with DTI, Oak Ridge, and NIA. And current plan is to have field testing next year, hopefully. So we are doing what we can to push this development forward as much as possible. So I want to talk a bit about what we learned through the years, and I think this is very important, trying to develop a new technology. It's constant trade-offs, no doubt. I think you can bring something forward that performs very well, but then it will cost a lot and perhaps have a problem with robustness as well. So we're always within this triangle, and for us, what we've been focusing on is simplicity. We want to have a very simple, robust system that is cost effective. It doesn't necessarily need to perform best in class. It just needs to perform good enough to be able to motivate a return on investment. So cost, simplicity, and robustness. And then, of course, considering the installers is very important as well, to be able to break the barriers needed to launch a product like this on a challenging market. And then, of course, understanding the future. It's constantly changing, no doubt, and to be able to adapt to the needs is of course important as well. So if we go into the technology, I think there is, as the last presenter talked about, there are several technologies that are used for gas heat pumps. absorption and chemisorption. So we are working with semi-absorption and absorption. Most current technologies are on the absorption side. They differ and have benefits and disadvantages, both of them. So instead of having 4 main components, we in the to be able to make it as simple as possible, we have went for the simplest sorption process possible. So we only have 2 main components, where ammonia is just moving front and back between 2 canisters, and we don't. It's a sealed system, so we don't have any pumps or seals or anything like that in our system, and that is something that we really see as beneficial for our technology, especially when it comes to robustness, but also costs and servability. So I will not talk too much about this. If you are interested to hear more, I would, please contact me, and then we can dig a little bit deeper into the differences between these technologies. So what have we done then? So what we've done is that we've taken a buffer tank, we integrated our thermal compressor into the buffer tank. We drive our thermal compressor with a burner boiler, and that the thermal compressor, of course, heat pumping from the environment, and that gives us a performance over 1. So I think that's the baseline of our system, and then we heat exchange to the buffer tank, which is a closed system. So one of our feature, which is quite unique and I think something that is needed for residential, to be able to be successful on the residential side, is to be able to do boost, because at high demands, the heat pump will not be able to give to meet those high demands. But with our design, we are able to do boost directly into the buffer tank, meet the customer demands with the same burner boiler as we are driving the thermal compressor. So it's a very interesting design that has this feature. And when it comes to sizing here, we can of course change the buffer tank size, which give you a benefit. You can change the burner boiler size depending on the needs, but also the thermal compressor size. So that's factors that can be moved around, and that's why we are talking about scalability of the system as well. So in summary, what makes our technology unique is the robust design. The only moving part is water pumps and a few valves and a fan. So we really try to slim that down. And then when it comes to cost effectiveness, we have been focusing a lot on commercially available products on the market. So there's only one component, which is the main thermal compressor, which is and not commercially available. And then, of course, when it comes to sizing and compactness, as you can see in the picture, we have squeezed the system into the form factor of a water heater. We build a bit on the height as electric gas heat pump, but we see that we can have the same form factor, everything included, in a tank, 40-50 gallon tank size. So I think that's a feature. And then, of course, being able to meet customer demands. That's in the end of the day, the customer want hot water when needed, and then to be able to direct fire into the tank and meet customer demands is a feature that we see will be rewarding us in the future as well. So as you understand, we are a development company. We are doing what we can together with our partners in the US to bring this technology to the market as soon as possible. Our plan is to join efforts together with one or several OEMs in the US, where we contribute with our knowledge, our development, but have a partner who helps us to bring this solution to the market as soon as possible. As I said, we are coming from many years of development, have done a lot of lessons learned through the years, which have brought us to the spot where we are with a very simple and robust design. So last year, we focused solely on subsystem optimizations to really make sure that every subsystem is separated and we know how it works individually. And then now this year, we're putting it all together, making an improved prototype that we will showcase both by ourselves, but also together with hopefully GTI and some North American manufacturers. And then, as I said, the plan for next year is field testing, which will be a big step for us and a closer step to commercialization of this technology. So key partners is of course very important. Having the support and knowledge from DTI, Oak Ridge, NIA, and OEMs, but also having financial support from both NIA, but also utilities and these groups supported by the utilities and DOE. So that is really what we are working on, doing this together with our partners and bringing this forward. So how can you support us in what we do? So as I've been talking quite a lot about, we have had support for many years from NIA and Oak Ridge, but also GTI. Right now, we're receiving support from several utilities in North America, which is very important for us to be able to move forward in the pace we'd like. And then, as I said, we are looking for manufacturers. So if you are a manufacturer and you are interested in these kind of technologies, we're really looking for the right fit. So we together can take on this effort to commercialize this technology. And then, of course, smart capital is always needed to be able to move forward as well. So that is also of interest. So I just want to finish off. I know there's quite many utilities on board. If you find this technology interesting, if you want to support us, please contact me or Aaron at NIA. And talk to him or me how you can support us. That's really appreciated. Thank you very much.
Great, Magnus, thank you so much. And to each of our speakers, thank you very much. I apologize for some of the technical issues that we had, but I'm pleased to say everyone got through their presentations on time and gave great content. So success overall. Given the timing here, what we're going to do is we're just going to move over to the Zoom room. So at the very top of the chat, if you'll note, there is an invitation and link to the Zoom meeting. The other thing that I found out yesterday is there's also the passcode for that meeting available in that link. So definitely make sure that you're getting both the link and the passcode so that you are able to join in the meeting. And with that said, I think it probably makes the most sense to thank all of our speakers for a great session. And we'll look forward to chatting with everybody in the Zoom here in just a moment. Thanks, everybody. Talk to you soon.